We're responsible for weights and measures here on the island. We conduct verification of all the weighing devices in the different sectors. Your retail shops, agriculture, fisheries, and also the health industry. We also do the verification of fuel pump dispensers. So we visit all the petrol stations around the island and we conduct verification just to ensure that the consumers are in fact getting whatever that they pay for. When they dispense a gallon of petrol, they're actually getting a gallon of petrol in their tanks, which is very important. So we're in the newly refurbished National Metrology Lab, and this was done under the strengthening the regional quality infrastructure project, funded also by CrossQ, which you just learned about. CrossQ in conjunction with CDB and also the European Union for the EDF. So we got upwards of 120,000 euro worth of new equipment, some of which you can is visible right here. We received 3 different comparators, where we'll be able to perform calibration services to our clients now. As I said before, we are involved in doing verification, but now we are expanding our services to be able to do calibration for our clients. So we received 3 comparators, a 5 kilogram, a 600 kilogram behind you right there, and then we have a 50 kilogram and we have a 5 kilogram in here. And also we received reference weights. So we're on island, we have the highest class of weights on island, so we'll be able to transfer that high level of traceability to our customers and our clients, which is on display right here. We have a set which ranges from 1 gram all the way up to 10 kilograms, F1 class. Yeah, so we had our commissioning last week, Wednesday, of our new lab, and this is a pretty big step here for us at the Metrology unit and also the Dominica Bureau of Standards. If you guys have any questions, I'll surely answer them.
How often do you go out to calibration?
We go out, verification is done every 6 months. So we have a set schedule, and sometimes if there are complaints from, let's say, the consumers, we work with the Ministry of Trade through Consumer Affairs, and we can go visit where that complaint was made. Let's say if it's a petrol station where a consumer feels that they're not getting enough petrol for the dollar quantity, we can in fact go do a spot check unannounced and perform our verification services.
Any chance you could show us how one of the equipment is used?
Okay, yeah, no problem. I hope the glove fits. Like OJ. Like OJ. Okay. So I'm just going to do the demonstration on the one at the back of you right here. Oh, sorry. So it basically displays the weight on the comparator, and then you'll have your readout right here. So that's where you record your value for whatever is placed on the comparator.
So when you go to the gas station, see, for example, you go to any gas station in Dominica, somebody files a complaint. How do you determine that the customer is being cheated or is not getting their gallon?
Okay, so when we go to the petrol stations, we work with our Seraphim test measures. So we have a 1 gallon canister, and then we have a 5 gallon canister. We perform a series of tests, 3 different tests, at 3 speeds which the nozzle can deliver. So we deliver it at a slow speed. The slowest speed you can deliver the product. Then the fast is where we fully depress the nozzle, and then you do a start and stop, where you pump, let's say when you're doing the 5 gallon, you pump 2 gallons, you cut off the pump, 2 gallons, you cut off the pump, and then 1 gallon. So once these tests fall within our parameters, our maximum permissible errors, then the pump is deemed working accurately. But if it's outside, then that goes with what the consumer was in fact complaining about. So then an adjustment will have to be done on that pump by the service technician of the petrol station, and then a test is done again just to make certain that it falls within our parameters.
But would it mean then that that pump, particular pump, will be shut down if it falls away from the parameter that you require?
Yes, if after, let's say, adjustment and subsequent re-verification, the pump does not meet our parameters, it is in fact shut down, then more measures will have to be done on part of the petrol company. If it's a part, let's say, is the metering or complete overhaul of the entire system. So the pump on a whole might just have to be replaced. And then we come in again, do our verification just to make sure that everything is in line.
You said the metrology unit, it was commissioned last week.
No, the lab. This lab was commissioned last week, September 14th.
Good morning, viewers. Once again, thank you for joining us. We are now doing a tour of the Bureau of Standards building. So we are doing a tour of the various labs and the various procedures which are usually being taken place and shown to us.
Now that we finished with metrology, and metrology also impacts what we do here, welcome to the Food and Environmental Microbiology Laboratory, which is the section that JANAC recently assessed for accreditation. Okay, so normally we would use codes. Normally you go in, have lab codes for to go in there and be signing, etc. But today we'll make an exemption to that rule. Okay, so welcome. We have no pathogens right now because of the problem, but he's eating all of this. Okay, folks, once again, let me say welcome. As you would have seen earlier, this is the area where we normally enter the laboratory, and as I told you all, depending on the samples that we have to do microbiological analysis on, they'll either be refrigerated or they'll go into the frozen section. And as you will see, one of the critical things we have for these laboratories is that the records of every piece of equipment, the temperature records must be kept on a daily basis to ensure that they're working within specifications. Also, the room also has to be at controlled temperature and humidity. So we monitor that in both this section and in the main laboratory section. Because in the main laboratory section, our working temperature is in the range of 20 to 28 degrees Celsius. That has to be the temperature working range. And a humidity of I think 40 to not more than 70% relative humidity. Okay, so this is where we normally store the samples prior to analysis. From here, we will take the samples into the main microbiology testing area, and let us move forward to that area. There's a lot more room. Okay, as I said, this is the main testing area. And as I said, we do a range of commodities. We can do food products, we can do feed, like animal feed, etc. We do here also air quality testing, water testing, but all these from the aspects of microbiological or environmental tests. Okay? Come in because I need to close this door. The first thing I will let you know is that every Monday the lab has to be checked for colony counts. Now, what does that mean? Because of the microbiological testing that we do, we want to make sure that there are very few bugs as possible that would contaminate or interfere with the results that we get from the products we analyze. Okay, so every Monday religiously, the entire area is swabbed, and then counts are done for microorganisms, basically. I won't go into which of them, but counts are done. And it must be below, if I remember correctly, what is known as 10 coliform forming units. Coliforms can work form the bacteria, etc. The count has to be below that for the room to be acceptable for us to do work. Okay, so that is done religiously every Monday. You will also see that on our right hand, this is where we do our temperature and humidity monitoring. And you see the temperature there is 21 degrees Celsius, and it also shows you the humidity. So every day we have to ensure that the lab is within the specified requirements for testing. Okay. This small piece of equipment here is what we use really for when we test in water quality. What we do what is known as microfiltration. So in these holders we'll have filters, and you pour the water samples into them and pull out via a vacuum, and then the colonies or the bacteria would be retained on the microfilter pads, and you would use that to do the analysis for water quality. Okay, and there are some critical things that we look for. I'm not a microbiologist by training, but I know that there are some basic things we look for. And what is the most important things is like things like what is known as E. coli and also fecal coliform are two of the most important things that we look for in water quality, among others, because if once you have fecal coliform or the presence of fecal coliforms, it means that your water is contaminated from basically feces, right? So you have to ensure that we don't have any of those problems with the drinking water or recreational water or whatever water that we do analysis for. Okay. And then we have the various pieces of equipment. We use this piece of equipment basically we would use when we go out again to do air quality checks in rooms or in offices, etc. This is the piece of equipment we would use. There's a plate in there with media, and you would put it down and we spin it in the room, and then it would draw air into it, and then you analyze the plate for whatever media, whether it's mold, primarily for whether you have mold growth or not, and the extent to which you have mold growth, if molds are found to be present. Because that's one of the tools we use for air quality testing. This, as I told you earlier, is the Biosity Cabinet that we use for when they have to work under basically sterile conditions. Okay, when work needs to be done under sterile conditions, it has to be done under this biohazard safety cabinet. Yeah. These rooms are our, as you see, our media prep room, which is inside here, where you prepare all the media that you are going to use for determining bacterial loads. Okay, bacterial loads, and after they've been plated and you put it, you screen it, if I remember correctly, then you would, as I said, we put them into the incubators at the relevant temperature, because not all organisms grow optimally at the same temperature. Okay, some grow optimally at, most of them, those that can harm us, grow optimally at body temperature. That is why if we ingest them and we have them, we can get sick. So we incubate them at the 35 or 37 degrees Celsius, and then for whether it's 24 hours, 48 hours, or 72 hours, you incubate them, and then afterward we do what we call the plate counts to see whether or not they are acceptable or unacceptable. Let me give you an example, because I'm also involved with Dexia, the Dexia Packhouse. Okay, Dexia Packhouse produces passion fruit pulp, and we export passion fruit pulp to Guadeloupe and other countries. To export the passion fruit pulp to the suppliers, we had to provide them with certificates of analysis, okay, both microbiological and chemical certificates of analysis, because there are specifications, for example, for total aerobic plate count, yeast and mold, whatever the organism may be, they must be of a certain level for the product to be accepted by the buyer. So we had to run all of those things here, and once the product met the required specifications, then we could ship that product to the supplier along with the certificate of analysis. Okay, so that's where a lot of things have to be done. And also lots of agro-processors come to us to do both microbiology work, microbiological testing, as well as chemical analysis testing. Water, we also get water tests with people who want to go into bottled water, etc., or look at the quality of the water that they're using. They also bring it here for microbiological testing, because again, it must be within certain limits to be acceptable. So we can tell you whether or not the microbiological limits for the product, whether they meet the specifications or they are out of specification. If it's out of specification, then we tell them that the product is unacceptable for human consumption, among other things, basically. And then they will take the corrective measures to ensure that whatever process they go back and do, when they finish and the samples are analyzed, that they're within specifications. Okay?
A question: Is the bureau, does it have the mandate to investigate that are doing spot checks or in any institution, or would you wait for a complaint before you go out and do an analysis of the situation?
I am not the expert in this one, and inspection will tell you exactly what happens, what mandates they have. Because mandates, again, depending on the legal mandate, it may fall within the Bureau's jurisdiction or the Environmental Health Department jurisdiction. So I'm not too sure exactly where it lies. But yes, if someone brings product to us and say, I have a question about this product, yes, we will do the analysis for them and give them the results of it.
Okay.
But we should also be able to pull, again, if you're a regulatory agency, and then again you have to know what your legal mandate is. But with regulatory agencies in other countries, they can pull products off the shelf and go and test them to see if they meet the requirements, to see if they meet the requirements for safe human consumption. Right? So we will get there eventually, but at this point in time, I am not 100% sure that that is our mandate, or we can legally do that. It may fall, as I said, to the jurisdiction of another department of the government.
Thank you. Understood.
And how long does results take? Like, for example, if you have to run a test, how long would the results come back?
We tell people basically 10 working days. 10 working days to get the results back. Because you'll appreciate the fact, for example, if we do microbiology work, right? Sometimes the plates have to spend 72 hours in the incubator. Right? So sometimes even on weekends, if you get work to do like plate on a Friday, then they come back. If they check, they may even come in on a weekend just to check and make sure the conditions are okay. Because you have to be put in Friday, you have to go Saturday, Sunday, Monday before you can do the analysis. In this circumstance where I said the incubation period is 72 hours.
What is the most used equipment in the lab? The most used and the least used?
All equipment, again, it depends on the test that you're doing. But the most used, I would say, for the most used equipment you have is the autoclave, which is here, because you have to sterilize everything prior to use that you're going to do. and the incubators. But remember, for the culture, for the plates to get to there, then you have to use equipment here to prepare them. So all the consumables, all this that need to be done with the different agars, what have you, you have to prepare them and use the water baths in all your preparatory work. Any questions for this
There
section?
we go. Barring the absence of any questions, I believe we have. No, I'm just talking to me.
Okay, folks. So I guess,
I believe we have had an.
as you said, barring the absence of any further questions, we can move on.
Yes, we can move. Is there something else we need to see here?
That's it.
There's another wing.
Okay. Well, we're moving from.
You haven't seen what all the $1 million equipment is, millions of dollars.
Oh,
And this is-
the Millionaire's Chamber.
And this and most of the equipment here we got from the European Development Fund and Cross-Q. European Development Fund via the NAO office in Dominica. Or in this way.
I'm very interested in seeing this other rooms. I believe Dr. Lambert mentioned the Millionaire's room. We call this one. So.
Equipment room.
Okay, we're gonna go right in there.
So we're just moving from.
We're going to do the section
A quick stop, a whistle stop.
very quick, which is also our conference room where we will. So we'll have Ms. Joseph give a brief description of the inspection duties.
You, Ms. Joseph? Okay. I'll probably just sit here so I can hold my mic up. Because I wouldn't want to take too much of your sphere.
So good morning everyone, my name is Ms. Keisha Joseph, Technical Officer for Quality and Inspection Unit. So here at the Bureau we have the Inspection Unit which has 3 subunits. So we have standards compliance, we have dump gap inspections and fresh produce inspections. So for standards compliance inspections, that is a subunit that work with local manufacturers in terms of the labeling requirements. So we do that on the 8 labeling standards, where we have prepackaged foods, goods, textile, brewery, just to mention a few. So also we work with exporters. That's why we do acid word processing. We also work with key stakeholders in terms of labeling requirements. So we have the graphic designers and so on. So we also conduct market surveillance. That is where we go out into the supermarket and conduct inspections of the goods that are on the shelf in terms of labeling requirements. We also have an office on the port by customs where we do acid word processing. We have another subunit called dump gap inspections. So with dump gap inspections, we have 4 farm assurers who are on the field right now, where they work with the farmers to prepare them for dump gap certification. I think Mr. Hansen mentioned about dump gap certification. So the farm assurers, what they do, they prepare the farmers. We also train the farmers. So you train the farmers in 3 areas of pesticide management, food safety, and first aid. So we work with key stakeholders like Ministry of Agriculture, Fire and Ambulance, and Environmental Health. We also have a 3rd subunit, which is fresh produce inspections. So this is done in Portsmouth and the Inland Reception Distribution Center, where we work alongside quarantine inspections. So all fresh produce for exports, we inspect the fresh produce. So where quarantine look at the pest, we look at quality assurance in terms of that. We also have a 3rd office in Portsmouth, which we opened in January this year, where it is a starting point for fresh produce inspection. So all in all, we have the inspection unit, which we are a total staff of 9 members, where we have 3 subunits: standards compliance, dump gap inspection, and fresh produce inspections.
How long does training take? Like, for example, training of the farmers. Is it done like monthly, yearly?
We do it on a yearly basis. So as part of the dump gap requirements, the farmers have to be trained in these 3 areas. So every year we train them and so on.
Okay, and is it like a month training? How long is often the training?
We do it basically in the 3rd quarter of the year. So we have it scheduled for the 5th quarter of the year.
And are they certified after the training is done?
After the training, we give them a certificate that they went through the training and so on.
No more questions?
Okay, and then from here, thank you, Mr. Joseph. And then we'll be moving along to the other areas so we can have an idea what happens in the other areas of this lab. Testing 1, 2, 3. And as we move here, I'm just gonna follow. Once again, we will join. Once again, we'll join Dr. Lambert as he continues to explain.
As you will see, the HVAC system is right now under construction in the aftermath of Hurricane Maria. We put back the HVAC system now. So this is where food microbiology will be done specifically, and then we will dedicate the other facility to more environmental testing work. Right? So there's no need to go in there with similar equipment as you have down there. You have similar equipment in here, but it's just not yet operational.
Okay, let's move on to the other units. Do what you said with this
Just moving. The convoy is moving, as you might say. In the other area,
this is the administration wing where we have a number of different units and offices. So right there is the director's office. Then we go next to quality assurance. Let's stop at quality assurance to get an overview. Today, our quality assurance unit is represented or run by Ms. Kazime, which is our technical officer for quality assurance. Is very instrumental in the accreditation of our labs in terms of documentation control and all of this good stuff. So Ms. Kazime, if you would just give us a brief overview as what you do here.
This unit, we deal with quality assurance, as the director said, everything quality. So we're responsible for all of the quality management systems for the various units. So right now we are developing the Metrology, QMS. We have also, as I think you have been meeting recently, conducted, Jana conducted an audit of our lab, Microbiology Lab, and we are almost in the process of getting accredited, so we're accredited, yay! And, also the focal point for accreditation, so any company, business that would like to get accredited, and they should get accredited, we are the link between the CABs, the accreditation body, which we have two in the Caribbean. They are JANA, the Jamaica Agency for Accreditation, and National Agency, Jamaica National Agency for Accreditation, and TTBS, which is the Trinidad and Tobago Laboratory something services. But TTBS, yeah. So any company that would like to get accredited, they need to send their information to us, and we can just assist them in facilitating the process of becoming accredited. So in terms of NFP. But as I said, my main function is bureau, developing QMS, quality management systems, so that all our services can be of the highest quality. So this is about what we do here. Okay?
thank you. Thank you so much. Really to the point. So we're moving on now, as we heard from Mr. LaRock, to another area here as we continue in this.
You can just give us a brief overview, Ms. Emmanuel, what you do really is the heartbeat of the bureau.
Good afternoon to all. I'm Ftir Emmanuel, Administrative Officer, Dominica Bureau of Standards. I'm Ftir Emmanuel of the Dominica Bureau of Standards. In my department, we have messenger, cleaners, and our communication officer responsible for our radio program, Standards in the Spotlight. As the director said, we are the heartbeat of the bureau. Without the administrative unit, we cannot function. So we deal with all human resource, applications, everything, and help with the day-to-day running of the Dominica Bureau of Standards. Thank you.
Okay, short and sweet. Let me move along. We have the Standards Development Unit, where you met Mrs. Barney Sampson. You can go in.
We heard from Mrs. Barney Sampson this morning on her presentation.
Members, but you heard Ms. Barney give a presentation as to what the overview of the Standards Development Unit entails. If you have any more questions, feel free. We have the unit, the manager, program manager, Ms. Mara Abraham, at the back. She runs the unit, so feel free if you have any additional questions to ask Ms. Abraham based on the presentation that Ms. Barnes gave earlier on. If not, then we just move along.
Yes, we move along.
We all good?
We're good.
All right, thank you. Thank you. And now we go to certification unit. You heard from Mr. Ansem, Mr. Heinrich Ansem. He's right there, and some of the staff members. If you do have any other questions or additional information and clarification that's needed based on the presentation Mr. Ansem gave, feel free. Otherwise, we go into the good parts.
Mr. Ansem?
Huh? Look, he's right there. Mr. Ansem is right there. Okay.
Yeah. So, thank you for your
yeah, thanks. So we have our finance accounting unit. It is really money matters here, so we don't have to ask much questions here.
So somebody said over there is the heart, this is the brain.
This is the brain.
That's where the money, the Ministry of Finance here.
Right. Without them I cannot function, so I need them. And now this section of the bureau, this wing of the bureau, the entire wing is a chemistry unit. And I'll present the technical manager again, Dr. Lambert, will give an overview of the entire unit, and you'll get to see the $1 million room that he's talking about. Right, so Doc, all yours.
First of all, folks, let me apologize for some of the stuff you will see in the corridor, because I told you earlier, the HVAC system is being established on the 3 wings, okay, it's been re-established in the aftermath of Hurricane Maria. So work is currently going on with the HVAC system being installed. Be that as it may, let us proceed to the chemistry wing, and let's start on this end. Stuff is being set up in all these labs as we speak. Okay, this is what we call the sample, is a sample reception area. Okay, so any sample that comes in to be analyzed will be brought to this sample area. And we have now what we call a LIMS system, a laboratory information management system, so that the product, all the information would go into the LIMS system, so that the product would be traced from arrival right through the entire testing, whether it's chemistry or microbiology. The product can be traced. So there's a chain of custody for any product that comes into the lab for testing. And it can be, as I said, traced from beginning to end. This for samples that are kept at ambient temperature, they'll be stored here. Okay, they will be stored in some of these cupboards, some of them which are locked, because the samples are always locked away, so they can't be interfered with. As I said, and the refrigerated samples and the frozen samples for both chemistry and microbiology would be stored in the relevant refrigerators or freezers. Okay, this is a piece of equipment we got. It was installed last week. Okay, this is what I spoke of, the ultra high performance liquid chromatography unit. Okay, and what that was, it uses liquids like solvents. You put a product inside here, and what it will do for you, it will separate the product into its component parts. Okay, it will separate the product into its component parts. So what come up at money come, it will stay in the system and it goes to a column. If it doesn't like it, it will just go straight through the column and out. Okay, that's what they're going to do. No affinity for it. Right? So some compounds will love the column, what is on the column more than others. So because that happens, I said they'll come off at different times. Okay? So that's the UHPLC, and one of the things we got is a backup power system. So in case electricity goes, it has its own backup unit that it will not shut down in case electricity goes. It has its own UPS and battery pack that is also to be installed. So it's not yet installed. Okay, so we got this from the International Atomic Energy Agency, the IAEA, this piece of equipment. Right. So let's move on to the other areas for the flow of what happens. This is an slightly interesting room today because we got someone who wants to get work done on sargassum, on the seaweed. So they brought it for us. They should have brought it dried, but they brought it wet. So we have to go through the whole process of drying it, etc., so the testing for it. And in this lab, we can do, we basically do moisture, as I told you earlier, moisture determination in foods. Any product, moisture determination in soils, moisture determination in foods, whatever the matrix may be, and we could use air convection drying for it, or we can use vacuum drying if the product is temperature sensitive. Okay, at 100 degrees Celsius, it may start to burn. So it will then be temperature sensitive. We'll run them in the vacuum oven at lower temperatures, okay, under vacuum. So, but these are normally run at 105 degrees Celsius or 135 degrees Celsius, depending on the product that we are drying. And as I told you in food analysis, one of the first things we do before we do testing for macronutrients, that is protein, fat, carbohydrate, the first thing we would do is determine the moisture content in the food. Dry it, and then we can test for the other products. That is just silica gel or what goes in that is being dried for use to keep products dry after. Keep it at the bottom of the tray to keep the product dry after we have dried it in the oven. Okay, so this is where we do basic moisture analysis for food and food products, or whatever the testing matrix may be. We have here the staff office, and right now between chemistry and microbe, we have 5 staff members. So this is the chemistry lab area. Okay. Now, this is the area, the rooms I really enjoy most because it's the instrumentation rooms. And trust me, I would not be surprised if the NCT is the most well-equipped lab in the OECS.
Oh.
It would not surprise me.
That's a plus for Dominica.
Yes. Lots of pluses, but we don't speak about it.
Yeah, that's right. Well, that's what we need to know so we can speak about it.
Yeah, that's it. Okay. Okay, folks, these are some of the lab analysts. Sorry, this is the lab supervisor, Mrs. Landa Sylvia, and this young lady is primarily in microbiology, but we train her to do some work in chemistry, and another big chemistry analyst. Okay. In this lab, as I showed you earlier, in this lab, for example, this is the AA, the atomic absorption spectrophotometer, where I said we can do elemental analysis. Okay, and I said elements, whether it is cadmium, mercury, lead, copper, arsenic, we can test for all these products using atomic absorption spectroscopy. And with the flame analyzer, we can go down to what are known, when you're testing for products, you can test ppm, what they call parts per million, in the food product. So we were using the flame analyzer for that. But there's also a graphite tube analyzer we can also use, where we can test products and get the quantities in parts per billion. Yeah, we can get them down to parts per billion using the graphite tube analyzer. And the VGA, which is on this side, is used for mercury, testing for mercury in products. Whether in fish or what have you, we can test for it. This is the FTIR, the Fourier transform. It's really infrared analysis, and excuse me, but we use it's for infrared analysis. In the infrared portion of the spectrum, of the electromagnetic spectrum, it will look for stuff in that region. And all the FT means that after the waves are generated, in this would have a mathematical equation called a Fourier transform that would make it into a spectrum that you can read. Okay, so we use this, for example, for testing. If you have a sample of a packaging material, right, and you want to know what packaging material is that, actually, we can use that and tell you this is that particular packaging material. As I said, this is a piece of equipment we also use for the bitumen testing on the banks of the Nile River. Yeah. We can also do, as I said, conformance testing with raw material ingredients. We can tell you, run this to the FTIR, and it will tell you whether or not the material is what it says it is, and whether it meets the specifications that you requested from the supplier. In other words, if we run, for example, ibuprofen, we can run, let's say, ibuprofen, and using a library, after it runs the scan, it will tell you, yes, this is ibuprofen. Right, so that's the kind of stuff we can use for that. This is Mrs. Lander's baby, which came in recently, which is the charm equipment, which does, for example, testing for antibiotics. It will test for antibiotics, like tetracycline. What else, Sylvia?
Pesticide.
Pesticide.
All kind of antibiotics, penicillin, all kind of antibiotics.
Alright, so it will tell you if you have antibiotics in the product that you want to use. Okay, whether it's milk, whether it's honey, whether it also tests, as I said, for aflatoxins, which you would find in grains, right? Corn, peanut, etc. It can tell you if the aflatoxin present, which can be harmful to human health, among a host of other things. Okay, so, and then we have the UV vis. Again, the names simply mean when you're running a test, like the IR tells you you're the infrared portion of the electromagnetic spectrum. You should have studied your science classes. Now you see how we're using it. What the UV vis tells you, it will test products in the ultraviolet, and the visible spectrum of the region. It will run analysis for you using the wavelengths in that region. Again, for conformance testing, it will tell you, using primarily colorimetry, the strength of the color that you have in the thing, it will tell you, it can quantify for you how much of an ingredient is in a product. Okay? We have your polarimeter. This is basically used for sugar testing. Like when Dex says you import sugar, it will tell you about the quality of the sugar that you're actually getting from the supplier. Whether you're getting what you've been paying for. That's what that piece of equipment will do for you. Right? If you have any questions, we can proceed. So, I won't tell you the cost of the equipment you see inside here. Okay, let's go.
We're going through another space here that we come through here, and now we're into another space. The folks are.
This and again the analysts, they're being trained by Thomas. Thomas is from Austria. He came in to set up, install, commission, and do training on the equipment. Right? This is what we call the LCMS, liquid chromatography mass spec equipment. Right? So they're being trained to use that right now. And as I told you earlier, all in these bottles you'll find it's liquids because they're solvents. Okay, and these are what are used to run, to analyze whatever we're testing. We're doing what? Pesticide radio analysis. What you want to do today?
Yes.
Pesticide radio analysis, right? So they're running pesticide analysis. Again, you can use any matrix and it will tell you what pesticides are inside there, if there are any, and you can also quantify the amount of pesticide inside there. This again was a gift from the International Atomic Energy Agency, the IAEA. Right? So you can just start counting when you go. You can go back and Google the prices of this equipment. And these are, as I said, what we basically use for doing wet chemistry. Right? Wet chemistry like crude fiber determination. Right? This is crude fiber equipment. We use this piece of equipment for doing protein determination. And there's another piece of equipment over there that we use for fat determination. So once we have the macronutrients, that is protein, we have moisture, protein, fat, carbohydrate, then you can use that information to prepare the calorie content on your nutrition facts panel when you look at a food product. Right? You will see fat content, you will see number of calories from fat, right? Protein content, number of calories from protein. So after we run these tests, we give them the data, and you can do the, as I said, the nutrition facts panel. And we also use the AA for running things like potassium, sodium. If you want to know the amount of potassium or sodium in the food, or calcium, we would use the elemental analysis. We would use the AA to run those analyses. We also do things like what vitamin C analysis and a host of other things. Okay. So Thomas leaves at the end of the week. So we have to get everything from him that he knows before he leaves. Right? So it's analyst in training. So we can go this way. We have one more room to see.
We have one more room that has Dr.
That and that costs over 700,000. That is equipment and the consumables. Right. That alone, that Gcms and the Emonews PLC. And the A costs over 100,000 US dollars. That was only.
And all this, the ability to do all these testings and analysis here. Do you lend services to the hospital, for example?
No, the hospital is involved in clinical testing, which is a different set of things that we do with clinical testing.
Okay, wonderful.
That aircon went down. We have to keep all the room at a certain temperature. Okay, now in this room, this is the GCMS, gas chromatography mass spectrometry piece of equipment, which would do similar work like the LCMS. But instead of using a liquid, which is liquid chromatography, it uses gas chromatography. That's the only difference between them. It uses a gas, so GC means gas chromatography, and LC means liquid chromatography. Okay, and in this, both of them, in other words, we run them through. Here, you run the samples through a column. Whatever you're testing, it goes through this column. That is where gas chromatography. The gas takes it through the column, and the gas will separate the components depending again on their affinity for the column, right? And after that is done, this is the mass spec. What the mass spec would do now is identify every single component of interest to you.
You have an example?
Okay, you have, let's say you have a mix of drugs, right? Because we actually ran the cocaine test on this, right? Let's say you have a mix of cocaine, meth, etc., etc. When you run it through the equipment, you will see they will come off at different times on the spectra that you get. You will see lines coming up at different times, and the lines would be different compounds.
Almost like ink, separating ink.
Well, you separate ink. You can separate ink into its different colors, but you put ink. There is like a little tank. You put it on your line and climbs up the stuff. That is liquid chromatography, but they call that one thin layer liquid chromatography. These are just more advanced methods of doing exactly the same thing, and more accurate and more sensitive. Right? So this is the mass spec, triple quad mass spec. She's laughing, I know. What does all that mean? All right? And what, as I said, what the mass spec will do is separate it into its various components. Okay? So if you run, let's say you're running a sample of, the police brought in something for us some time ago, right, Million? Right? And they didn't know what it was. Right? So we ran this sample through the GC, right? And at the end of the day, they told us it was, the GC told us it was it was meth.
Oh, wow.
Right? It was meth. It tells you this is definitely meth. It gives you the molecular weight. It gives you the structure of the compound. It will do exactly the same for cocaine for you. With pesticides also it will do exactly the same and tell you what pesticide is in your product. Right? So across the spectrum, you can also do urinalysis with that also to tell you if you have drugs in your system. Both that and the LCMS will do that for you. Right? So as I said, we do a lot of testing for foods and other matrices. But the plan, one of the plans going forward is to develop our forensic capabilities. Forensic capabilities. So no longer would drugs have to be taken abroad for testing to know exactly what drug it is. We can do that right here. The only issue right now, again, it goes back to the whole issue of accreditation. You have to be an accredited lab, you know, to go in court and stand up and say, yes, we tested and it is that. When the expert goes to give expert testimony, that's when the thing they will ask you, was that done at an accredited lab? So we are in the process of accrediting the chemistry section. We're finished with the food and environmental microbiology. We're in the process of doing the chemistry section with the assistance again of the IAEA. Okay, so that's the suite of equipment we have on this corridor.
And we want to thank Dr. Lambert.
That's it for now. All the stuff down there is just stuff, rooms for with the HVAC equipment. So that's basically the tour, folks. I hope you enjoyed it.
We want to invite you.
One last little thing that we're planning to set up, but we have not done yet. You see, we have stuff to do PCR work inside here and also ELISA work, but we've not set it up yet. It's just a matter of space and human resource.
So with this,
I know you can see that, right? But it's okay, we can go now, we can have snacks now, it's all right?
Yes. Look the director now.
No, but
We can go back to the room we were in the presentations, and we'll have snacks and lunch and whatever.
We would like to thank you, each and every one of you, for joining us today for the Dominica Bureau Standards Media Sensitization Session 2020 and also the tour. On behalf of Emonews, we would like to also apologize for the low audio which was observed in the first session, and we have resolved this issue. Once again, thank you for joining us today, and we do wish you have a blessed